Hey guys, welcome. We're going to do our review video using one of our ICs actually. This was regressive math, and let's go ahead and get started. So first of all, what we have here is, got to explain quite a few things here. Arc AD, right there, if you see there's this angle here and this angle here are inscribed angles, and they open up to the arc AD. So what that means is these two are actually congruent. So we can just do 11x minus 3 equals 8x plus 15. And then I'm going to subtract 8x from both sides. And I'll move 3 over at the same time. And I'll get 18 over here, and this is going to end up with 3. And divide by 3, I get x equals 6. Now again, the question says solve for MAD. I don't know, or sorry, not MAD, the measure of arc AD. So I need to go ahead and substitute it back in here. So we're going to get 8 times 6 plus 15. And I have my calculator off screen here. 8 times 6 plus 15 is going to give me 63. That is the interior angle in there, but we have to double it. Remember, an inscribed angle gets doubled, so times 2, we get 126 as the measure of arc AD. Alright, number 2 is not a particularly favorite question of mine because it's kind of hard to actually do if you do it in a certain way. So this is the way that I have figured out how to do it. But RQ is this arc right here, and we're trying to solve for its measure. What we can do is 71 is this angle right here, and it's opening up to QT right there. So if I double 71, I'm going to get 142, and this yellow line RT is a diameter, so that means this whole other side is going to be 180, so I can do 142 and subtract it from 180, I'm going to get 38, and that's going to be what's left over. So the measure of RQ is 38 degrees. Alright, number 3. Okay, so we want to find the measure of EF, which is actually right here. Okay, but to do that, we have, these are diameters, and these are vertical angles, so they're congruent, which means their arcs are going to be congruent as well. So we set these equal to each other, and subtract over, and we get 2x, and add that over, we get 10, x equals 5. Again, that doesn't really help us yet. We got to plug it back in. We get 13 times 5 plus 3, so 13 times 5 plus 3 is going to give us 68 degrees. Now 68 degrees is not the answer. 68 degrees is this portion right here. And if you add the GF and EF, it's going to make 180 because this is a diameter. So we're going to get 180 and subtract 68 degrees, and we're going to get our answer of 112 degrees equals the measure of arc EF. Okay, this one's pretty tricky here. First, what we got to do, these are congruent to each other, so we'll solve that in a second. But if this is 15, that means this is 15. And then if I do 52 minus 15, I know that this is 37 and this is 37. So finding out all those pieces is crucial. Now, those two are congruent because the point with a tangent, we're going to set those equal to each other. And we can subtract 7x over here. That's going to leave us with 6x. Add 8 over there. That's going to leave us with 12. So x equals 2. And then plug it in. We're going to get 14 plus 4, which is 18, and 18. So really what I have to do is I have to do 2 times 18 plus 2 times 37 plus 2 times 15. And if I do all of that correctly, we should get 140 as the perimeter. My birthday? That's easy. I know school's out, but I still accept gifts. Okay? Alright, the circumference of a circle that has an area. So first of all, the area formula is pi r squared. So if we know the area, we can actually solve for r. So divide by pi. And 530.66 divided by pi is going to be 168.91 equals r squared. Then take the square root of that. And r is roughly 12.9, repeating almost. And then we're going to put that into 2 pi r, so we're going to get 2 times pi times 12.9. Now I have it in my calculator already, so I'm just going to leave it in my calculator. So I'm going to multiply it by 2. So I'd get about 25.9 pi, but that really doesn't make sense to leave it like that, so then I'm just going to multiply it by pi, and we're going to get 81.6. A lot of people found the area of the non-shaded region. First of all, I'm going to do 360 and subtract 65, and I'll get 295. Okay, so that's the shaded region here. So what portion of the circle am I looking at? I'm looking at 295 out of 360 times the area of a circle, which is pi 15 squared. And all we have to do is plug that in our calculator. 15 squared is 225 times 295 divided by 360. And then you get 184.3, but I'm just going to multiply everything by pi, and we should come up with 579.2 as our square centimeters answer. Okay, I like this problem, but instead of trying to solve for x, I'm actually going to solve for this whole portion here. I'm going to call it whatever I want. It's the hypotenuse, so I'm going to call it h. So h is the whole distance here. And so what I'm going to do is I'm going to do 15 squared. Now we know this is going to be 90 degrees, that's why I can use Pythagoras Theorem. 18 squared equals h squared, the hypotenuse. So we get 15 squared plus 18 squared is going to give us 549 equals h squared. Then take the square root of them. And the square root of that is about 23.4 is h. But I just want the x. Now, this first part is 15 because it's the radius. The radiuses are congruent. So 15 plus x should equal 23.4. So subtract the 15, and we should get about 8.4 as the measure of x. Number 9 was a tricky one here. It's, again, now we know that the radiuses are congruent. This is a radius and this is a radius. And so we know that we have 7 here. That means this has to be 9 because 9 plus 7 makes 16. And then I can create a little right triangle here, and we can find AB. So we're going to get 9 squared plus I don't know squared equals 16 squared. Doing this fast, I can square these, subtract them, and I'm going to end up with 175. Take the square root of it, and we're going to get about 13.2, but that's only for half of the distance, so this represents only this little piece. So I want the full length of AB, so I got to multiply this by 2. And again, I already have it in my calculator, so I can just go ahead and hit times 2. And I'm going to get, it does radical form, 26.4. And I'm doing kind of just like very basic rounding here, so don't get too upset. Last one here, find the arc length of DE given the radius of 8. So arc length requires me to find the measure of DE's first. So that's this piece right here. Well, I got 52, I got 90, and then I got, I don't know. So we can just do 52 plus 90 plus x equals 180 because it's a diameter here. And so solving for that, we'll just do it quickly in my calculator. I'm going to get 38. So this is 38 degrees in here. The arc is also going to be 38 because this 38 is a central angle. Central angles are congruent to their arcs. it's inscribed angles that aren't, but this isn't an inscribed angle. So we're going to get 38 degrees out of 360 times 2 pi 8, or 2 pi r. And again, we're going to just throw all that in our calculator and see what we get. Okay. And I got about 5.3, and I just multiplying everything in there is going to be the length of DE. And there it is. Alright guys, thanks for the work. I mean, look at that, boom. That's going to be very similar to our quiz that we're going to see. Okay? Alright guys, Shasta, pasta.